Hello, everyone. So beautiful
Fine.
to be here with each and every one of you. Are you ready for today's class?
Yes, sir.
All right, I'm fully ready for today's class as well. Can you see what's on the screen?
Yes, sir.
Beautiful. Can you read what's there?
Empirical formula.
Yeah, empirical formula. So we're going to be learning the basics of empirical formula today. Are you all ready for today's class?
Yes, sir.
Good. So here are some of the learning points or some of the things that I want you to be able to achieve by the end of today's class. First of all, I want you to be able to state what an empirical formula is. So, should you get stopped by anyone at random on the road and then you're asked, Francis, Nifemi, whatever your name is, and they're saying, what is empirical formula? You should be able to explain to them what it means. Am I communicating?
Yes, sir.
Beautiful. And then next up, I want you to be able to compare the molecular formula and the empirical formula for a compound. You should be able to tell what the differences are. And then finally, I want you to be able to carry out the formula calculation for the empirical formula. Are you ready for the class right now?
Yes, sir.
Good. So on the screen right now, I have the two definitions for the two concepts. In our next class, we're going to be seeing what molecular formula is, but for a foundational definition, I want you to be able to differentiate what it is. So first of all, we have what the molecular formula is, and it says the molecular formula is a formula that gives the total number of atoms of each element in a molecule of a compound. So for example, now let's say I have this molecular formula H2O. Francis, what compound is this?
Water.
Very good. This is water. And this formula is simply telling you that in the compound water, it contains hydrogen. How many atoms of hydrogen are there?
Two.
Very good, two. How about you, Nifemi? How many atoms of oxygen are here?
Two.
How many atoms of oxygen?
Two.
Are you sure? Check again.
Um. Okay. One.
One. You can see that there is nothing in
Yes.
front of oxygen over here. So it is simply telling you that you have just one atom of oxygen. So that is what a molecular formula is. It's a formula that gives you the total number of atoms of each element that are present in a molecule of a compound. Empirical formula, on the other hand, is a formula that gives you the proportions or ratio. Do you know what ratio means? It's open. It's open. Yes, yes, it's open. Um, hold on. Hold on, guys. Let me get a glass of water. I'm coming. Hello, can you hear me?
Yes, sir.
Let me get a glass of water. I'll be with you guys in a moment. Hello, guys. Can you hear me now?
Yes, sir.
All right. Sorry about that. I needed to attend to some stuff. So I was defining what the empirical formula of a compound is. And then I said the empirical formula, on the other hand, gives you the proportion or ratio. Then I was asking a question. What is the meaning of ratio? Who wants to help us out? Yes. What's the meaning of ratio? Nifemi, Francis, anybody? What's the meaning of ratio? Who wants to try? Bukumi.
A ratio is like a comparison of two things.
Okay, okay. Ratio is like a comparison of two things. All right, let me help you out. A ratio is a mathematical statement that tells us the amount of each okay, let me explain it this way. For instance, let's say I have 40 boys and 60 girls in a class. If I say divide this to its lowest term, what number can divide 40 and divide 60? 10 can divide the both of them. So if I divide 40 by 10, that gives me 4. And if I divide 60 by 10, that gives me 6. Can any number divide 4 and 6? Yes. Can any number divide 4 and 6?
Yes.
What number?
2.
All right, 2 divides 4 gives us 2, and 2 divides 6 gives us 3. So this is the ratio 2:3 for 40 boys and 60 girls. That is what the empirical formula is. It is a formula that gives us the proportions and the ratio of elements present in a compound. Now, here is what we mean. For example, look at this on the screen. This is the molecular formula for a compound. This compound is called dinitrogen tetraoxide. Can you see what's on the screen right now? This compound that I'm circling.
Yes, sir.
Beautiful. This is the molecular formula. But the empirical formula, look at these numbers, number 2 and number 4. Is there any number that can divide number 2 and number 4? Of course,
Yes,
number
sir.
2 can divide both of them. 2 divided by 2 gives us 1, and 4 divided by 2 gives us 2. So you have 1:2. And that's why the empirical formula over here is NO2. 1 atom of nitrogen and 2 atoms of oxygen. Did you get that?
Yes, sir.
How about you,
Yes, sir.
Nifemi? Bokumi, are you following? All right, beautiful, beautiful. Here is the next example. This is the molecular formula for this compound. This compound is called butane. 4 carbon atoms and 10 hydrogen atoms. So if we were to break this down to its lowest term, we have 4 and then we have 10. 2 can divide both of them. 4 divided by 2 gives us 2 and 10 divided by 2 gives us 5. So the ratio is 2:5. That's why we have C2 and H5 as the empirical formula. Are you guys seeing how we are breaking down the molecular formula into the empirical formula?
Yes, sir.
Beautiful. Is anybody confused or lost? Is anybody confused or lost?
No, sir.
All right, beautiful. Here is the next example. We have this compound on the screen right now. So six atoms of carbon and 6 atoms of hydrogen. So if we were to break this down to its lowest term, 6 and 6, both of them can be divided by 6 and 6 as well. So the ratio is 1:1. And that's why you have the empirical formula here to be CH. Are you all with me?
Yes, sir.
Good. So now I want you guys to do this for me. Convert these molecular formulas into empirical formulas by finding the smallest whole number ratio. Francis, do number 1.
Yes, sir.
C6H6. What would the empirical formula be?
1:1.
Thank you very much. 1:1. So therefore, if we put it into the formula, it now becomes CH. Is that correct?
Yes, sir.
Good. Nifemi, do this one. Nifemi, are you there? Nifemi, are you there? Okay, if Nifemi is not there, Bukumi, go ahead, do it. How about you, David? Do you want to attempt it?
2:5.
Okay, so we have P4 and then O10. The ratio becomes 2:5. 2:5 put into the formula now becomes P2O5. Is that correct?
Yes, sir.
Beautiful. So who wants to do this one for us? The last one.
Me, sir.
Who is speaking? Francis. No, Francis, you've
Frank.
done one. I want somebody that has not done one before. Nifemi. Yes. Can you do this last one that is on the screen?
mm, oh my God. Yes.
All right, go ahead.
Six is going to divide it.
Okay.
God.
So if we have the numbers 6, 12, and 6, we divide all through by 6. So doing that, what do we have? We have 1
We have
ratio 2 ratio 1. Is that correct?
yes, sir.
So what would the empirical formula now be? Mm-hmm.
CH2O.
CH.
CH2O.
Beautiful. Beautiful. Every one of you have answered my questions correctly well. So now the next thing we're going to talk about are the steps you need to take in order to determine the empirical formula for a compound. Step number 1 says, Nifemi, read it for me.
Um, to determine the empirical formula, obtain the
Yes.
percentage contribution of each element.
Okay.
If the values are given as percentages and convert percentages to grams.
Good. That's number 1.
If the
So
values
hold
are
on. You're reading just number 1. Someone else is going to read the second point. So here is what we mean. If they give you a question and then they give you the values in percentages, what you are simply going to do is convert the percentage into grams. So for example, if they say a compound, a compound contains 50% carbon and then 50% oxygen, for example, step number 1 to determine the empirical formula is to convert this percentage into grams. So instead of writing percent, you just simply say 50 grams. Do you understand?
Yes, sir.
Good. All right, Francis, read number 2.
If the values are given in grams, convert grams to moles.
Okay.
Divide by the atomic mass.
So here is what step number 2 simply means. If they didn't give you the value in percentage, they gave you the value in grams directly. So for instance, they say a compound contains 2 grams of carbon and then 5 grams of oxygen. So to get the empirical formula, the first step you're going to do is to convert these grams into number of moles. How do you do that? You simply divide these two by the atomic mass of carbon. The atomic mass of carbon is 12. Okay, so you're just simply going to say 2 divided by 12. Are you all with me?
Yes, sir.
Don't worry, we're going to take it
sir.
step by step. And then the final step, Nifemi, read that. Or David, I want you to read that. David, read that. David, are you there? I want you to read that. Okay, if David is not there, Bukumi, can you read that for me?
Divide all values by the smallest mole quantity.
Good. So for instance, now, when you, let's say you have 5 grams of carbon and then 2 grams of oxygen. By the time you obtain the number of moles, and then let's say carbon is now 1 mole, and then oxygen are 2 moles. The next rule says you are going to divide by the smallest mole quantity. Between 1 mole and 2 moles, 1 mole is smaller. So you are going to now divide all through by 1. So now let's impute these steps and apply them and see how we can gain the empirical formula for some compounds. Example number 1. Somebody read this question for me. Bukumi, read it for me. Bukumi, read this
A
question for me.
compound
Mm-hmm.
a compound contains 40.0% carbon,
Okay.
6.7% hydrogen, and
Mm-hmm.
53.3% oxygen. What
Okay.
is the empirical formula?
So you have seen over here, they've given us the
Carbon equals to
Yes, all these over here are the atomic masses of all the elements they have mentioned. So now, who is helping me with this step one? Can you read out what step one says we should do? Did anybody write out the steps? Did anyone write out the steps? Who can help me out with what step one says we should do? All right, let's go back a bit. Everybody write out the steps now. When you are done writing the steps, just let me know that you are done so that we can move on.
You can't pause.
Have you written the steps out now? Have you written the steps now? Bukumi, David, Francis, Nifemi. Have you all written the steps now?
Hello, please.
Yes,
Francis
sir.
went to get writing materials. Please, he's coming.
Okay. Francis, you didn't come with your writing materials. How come?
He's not here now. He's coming, please. He's coming.
Okay. All right. No problem. Bukumi and Nifemi, I hope you're writing them down. These are the steps to get the empirical formula. Once you're done writing them, just let me know.
Yes, sir.
All right. Beautiful. So since you're done, let's proceed.
Sir,
Yes?
please, I wasn't done. I went to go and get my writing material.
Francis, are you back?
Yes, sir.
Oh, how come you came to class and you didn't bring your writing materials? Please, whenever you're coming to class, make sure you come with your writing materials, okay?
Yes, sir.
It's very, very important so that you can jot down the points that you need. All right, go ahead and write down the steps to get the empirical formula. When you're done, let me know. Apart from Nifemi, who else is done writing? David, are you done?
Yes, sir.
How about you, Bukumi? Are you done?
Yes, sir.
Okay, so let's hold on for Francis to finish and then we'll proceed. Now we have the first question that we want to treat, and we've already read that out. So step number one, what is the first step? Somebody read it out for me, please. Step one.
Obtain the percentage composition of each element. If the
Okay,
values are given to you as percentage,
good,
convert to percentage grams.
good. So now, first things first, what are the elements that are present? We have carbon, we have hydrogen, and we have oxygen. And then they say obtain the percentage composition of each element. Carbon is 40%. Is that correct?
Yes, sir.
Nifemi, how many percent is hydrogen?
6.7.
Good. Bukumi, how many percent is oxygen?
53.3.
53.3%. Thank you very much. The next thing that is said is that you are to convert those percentages into grams. So now, instead of writing percent now, I will just simply come and change that percent to grams. So for carbon now, instead of writing percent, I'll just come in front of carbon and write G. Are you all following?
Yes, sir.
Good.
Okay.
And then for hydrogen and oxygen, I'm going to do the same thing as well. For hydrogen, I'll come to the front and write G. And then for oxygen, I'll come to the front and write G. I have converted them into grams. Are we all there?
Yes, sir.
Beautiful. The next rule, what is the next step?
Um, if the values are given
No,
in
no, no, no,
grams,
no.
convert.
After converting the percentage to gram, it says we should convert it into number of moles. Is that correct?
Yes, sir.
And how do you convert to number of moles?
Divide by
The atomic
divide
mass.
by atomic mass.
Thank you very much. David, thank you very much for that input. So we'll divide by the atomic mass. Now, what is the atomic mass for carbon?
12.
12.01. You can see it over here from the question. So what are we going to do? We're going to simply say 40 divided by 12.01. Bukumi, are you there? And then for
Yes, sir.
hydrogen, thank you very much. For hydrogen, we'll divide by the atomic mass. Hydrogen is 1.008. And then oxygen, we'll divide by the atomic mass, which is 16. So now, first things first, 40 divided by 12.01. That gives us, I'm with my calculator here, that gives us 3.33. David, 6.7 divided by 1.008. What's the answer? This should give us 6.65. And then the third one, 53.3 divided by 16. That gives us
3.33.
3.33. Thank you very much. Did you all see how I got the answers? 3.33
Yes, sir.
moles. Over here, 6.65 moles. And then over here, 3.33 moles. Now, Bukumi, what is the next step that we are to take? Bukumi, are you there? Okay,
Good afternoon, sir.
good afternoon. All right, if Bukumi is not there, David, can you tell us the next step to take?
We are to divide by the smallest value.
Thank you very much. What is the smallest value among the three of them now?
3.33.
Thank you very much. So the smallest value is 3.33. We are going to say 3.33 divided by 3.33. The second one, 6.65 divided by 3.33. And then the third one, 3.33 divided by 3.33. Hello guys, can you hear me? No,
Yes,
not you.
sir.
Yes, sir.
All right, so 3.33 now divided by 3.33. We're going to have 1. And then for the second one, 6.65 divided by 3.33.
1.9.
Thank you very much. 1.99. If we approximate this, what are we going to end up with?
2.
We are going to end up with 2. Thank you very much. And then the last one, 3.33 divided by 3.33, we have 1. So altogether, let's impute our values. For we have 1:2:1. So for carbon, it will take number 1. For hydrogen, what number is it going to take?
Number 2.
Thank you. And then for
That's it.
oxygen, what number is it going to take?
Number 1.
Thank you. So writing the empirical formula, we're going to have CH2.
2, 0.
This is not 0, this is O. Okay? Let's not make that mistake. Did you see how I calculated it?
Yeah, sir.
Beautiful. Can we take another example?
Yes, sir.
All right, so here is example number 2. Aluminium chloride is a compound. A sample of aluminium chloride contains 0.135 grams of aluminium and 0.533 grams of chlorine. Work out its empirical formula. So, David, what is step number 1?
We have to obtain the percentage composition of each element, then
Okay,
convert it to grams.
convert it to grams. What is step number 2? Step number 2 says if it is not given to you in percentage, right?
Yes.
What are you to do?
Yes, sir.
If the values are given in grams, convert to moles.
Good. So now let's write the name of the elements first. Aluminium chloride is a compound. What are the elements that are present?
Aluminium and chlorine.
Aluminium.
Aluminium and chlorine.
Thank you very much. Aluminium is there, and then chlorine
Chlorine.
is also there. How many grams of aluminium do we have?
27.
With
How many grams
7.
of
Oh,
aluminium? I'm not asking for the atomic
zero
mass.
point
How many grams of aluminium do we have? The mass,
0.135.
0.1.
0.135.
Thank you.
0.1.
How about chlorine?
0.533.
0.533. So now I've gotten the grams for the two of them. The next rule says I am to convert it to number of moles. How will I do that?
What's the number of moles? Divide by the atomic mass.
Thank you very much. For those of you that don't know why we are dividing by the atomic mass, it is there in the rules. When you have gotten the amount of mass or the amount of grams for each element, you divide it by the atomic mass to get number of moles. So now what is the number of moles for aluminium, or the atomic mass for aluminium rather?
7.
7.
27. Thank you very much. What is the atomic mass for chlorine?
35.5.
Thank you very much. 35.5. So now the next thing we're going to do is punch our calculators. The first math or the first arithmetic is saying 0.135 divided by 27. We are going to have
0.005.
0.005. Thank you very much. I'm so excited you're following. And then for the second one, we have 0.533 divided by 35.5. We're going to end up with 0.015. Are you all with me?
Yes, sir.
Good. So now next step, what is the next step to take?
Yes, sir.
Divide all values by the smallest quantity.
Thank you. So we have 0.005 moles and we have 0.015 moles. Bukumi, which one is the smallest between all the number of moles that we have?
7.
Okay, let me throw the question open to the whole
Zero point
class.
zero zero five.
Thank you, David. 0.005. So we are going to divide all through by 0.005. So we have 0.005 divided by 0.005. And then we have 0.015 divided by 0.005. So if we punch our calculators, the first arithmetic is going to be 1. And the second one, we have 0.015 divided by 0.005. The
Gives
answer
us
is going
3.
to gives us 3. Thank you very much. So we have 1:3. So the first element is going to take the first ratio. Aluminium is going to take the number 1, and then chlorine is going to take the number 3. So the final empirical formula is going to be Al. Since it's number 1, we will not write it. And then Cl3. Did you all see how I did it?
Yes.
Yes, sir.
No, sir.
Do you want to try one example?
Yes, sir.
Oh yeah, everybody do this one. I'm waiting for the answer right now. Are you all with me?
Yes, sir.
Yes, sir.
Good. David, Francis, Bukumi, David, and Nifemi. go ahead and do this. I'm waiting for the first person to give me the correct answer. I hope you can all see the question on the screen, right?
Yes, sir.
Beautiful.
Uh,
Who is done? Bukumi, Francis, David, Nifemi. The two Davids in the class. Actually, we happen to be three Davids. So are you sure all of you will not pay for this, my name that you are sharing like this?
uh,
1:2.
1:1.
Ratio
I don't want you to just give me the ratio. Give me the actual empirical formula.
Maybe O2.
PbO2. Who has another answer apart from this one?
is PBO.
Okay. Someone else is
PbO.
saying PbO2. Who else?
PBO2.
I hope all of you that are shouting PbO2, you solved it. Not that you're just shouting PbO2 because other people are shouting PbO2. All right, let's solve the question together now for those of us who may not understand. So step number one, what do we do? Bukumi, let me hear you. David, step number one, help me out.
So I don't know the answer. I was not here in class.
There is no problem. How about you, David Ibukwe? Can you help me with step number one?
Obtain the percentage composition of each element.
Okay. Now, this wasn't
If
given to us in percentage. So what's the next thing we're going to do?
we percentage grams. We If the values are given to you as percentage, convert the percentage grams.
Okay. So the values were not given to us in percentage. What are we going to do now?
We
Read the second rule now.
If the values are given in grams, convert grams to moles. Divide
Simple.
by atomic mass.
So now we have the first element, which is lead. Lead is actually Pb. And then we have the second one, which is oxygen. Oxygen is O. So now, the amount that they gave us was in grams. How many mass of, what's the mass of grams that they gave us in lead? How many grams of lead do we have?
6.21.
Thank you. 6.21 grams. How about oxygen? How many grams?
0.72.
So we're going to convert this to number of moles. We divide by the atomic mass. The atomic mass of lead is 207, right?
Yes, sir.
And the atomic mass of oxygen is 16. So if we divide 6.21, I hope you're seeing it, 6.21 divided by 207, we have 0.03. And then if we divide 0.72 by 16, we have 0.045. from these points now, what is the next thing to do?
Calculate the small. Which one is smaller? Use the
Thank
one
you.
that's smaller.
Thank you very much. So the smaller one, which one is the smaller one now among all of them?
0.02.
Thank you.
0.
So thank you, 0.03. So we say 0.03 divided by 0.03, and then we have 0.045 divided by 0.03. This one over here is going to be equal to 1, and this one over here, 0.045 divided by 0.03.
Okay.
1.5.
Good. It's going to be equal to 1.5. If we approximate this, what is it going to be equal to?
2.
Thank you very much. 2. So finally now,
2.
we have the ratio, which is 1:2. So the formula or the empirical formula is going to be PbO2. Did you all see this?
Yes, sir.
Beautiful. So one more question to solve, and then we can call it a day.
Okay, sir. Okay.
All right, you guys go ahead and solve that. I hope you can see the question on the screen.
Yes, sir.
All right, go ahead and solve that.
Okay. So carbon is 1, chlorine is 4.
So give me the empirical formula. See what?
CCl4.
Okay. Let's wait for the others to be done. Who else has another thing to give us an answer? CCl4.
ACO4.
CCl4, okay. Who else? Yes, who else?
CCl4.
Okay. So now let's solve it step by step and let's confirm. Step number 1 says we are to obtain the percentage composition of each element. Now the values was not given to us in percentages. So we have carbon and we have chlorine. What is the mass of carbon that was given to us?
0.36 grams.
0.36 grams. So we have 0.36. Let's write that out. 0.36 grams. And then the second one, which is
4.2.
chlorine, 4.26 grams. Let's write that out as well. 4.26 grams. So the next thing to do is to convert it into number of moles by dividing with the atomic mass. The atomic mass of carbon is 12 and chlorine is 35.5. So we have over here divided by 12 and over here divided by 35.5. Are you all following?
Yes, sir.
So we have 0.36 divided by 12. That gives us 0.03. And then we have 4.26 divided by 35.5. We have 0.12. What is the next step to take at this point?
Divide by the smallest number.
Divide by the smallest number. Thank you very much. What's the smallest number?
0.03.
So we have 0.03 divided by 0.03, and then we have 0.12 divided by 0.03. 0.03 divided by 0.03, the answer to this arithmetic will be 1. And then we have 0.12 divided by 0.03. The answer to this arithmetic is going to be 4. So we have 1:4. Remember, our elements are carbon and chlorine. So carbon takes number 1 and chlorine takes number 4. So the empirical formula will now be CCl4. I'm so excited you guys did it correctly. I'm a proud teacher right now. Give yourselves a round of applause. Even though I can't hear you clapping, I know you are clapping for yourself. So here are some assignments that I want you to carry out for me. I have 3 questions. Question number 1, question number 2, and then, okay, just 2 questions. Question number 1 and question number 2. So I want you all to write question number 1 for me and tell me when you're done. So I'll show you the question number 2 as your assignment, and then you can go home and do that. Can you all hear me?
Yes, sir.
Beautiful. All right, write question number 1 out then. Nifemi, can you hear me?
Yes, sir.
All right, beautiful. Hope you can see what's on the screen. I want you to write the assignments out. When you're done, then everyone will write out the second question. Those are your assignments.
Done.
Are you all done writing?
No,
I'm
sir.
done.
Who is still writing?
Francis.
All right, Francis, hurry up.
Thank you, sir.
When you're done, just let me know. So I'll move on to the next question for you guys to write, and then we'll call it a day for today's class. So while we're waiting for Francis to get done, Nifemi, can you define for me what a molecular compound is? And then after that, Bukumi, you define what an empirical formula is. So Nifemi, define for me what is a molecular formula?
A molecular formula is the number of atoms of each element in a molecule of a compound.
Thank you very much. A formula that shows the number of atoms of each element in a molecule of a compound. Beautiful. How about you, Bukumi? What is an empirical formula?
So I'm done.
All right. Before we proceed, Bukumi, define for me what an empirical formula is. David, can you define for me what an empirical formula is? Since Bukumi can hear me clearly. David Ibokwe.
Empirical formula of a compound is the simplest formula, which gives the whole number ratio of the component elements.
Oh, thank you very much. That's beautiful as well. So Everyone write out the next question, which is the final one, and then we'll call it a day. David Ibokwe, if I have the molecular formula for a compound to be C2H4, what would the empirical formula be if I break it to its simplest term? Can you let me know?
It should be CH2.
Thank you very much. Because these two over here can be divided by 2, and this 4 over here can be divided by 2. So we have 1:2. That gives us CH2. Beautiful. Now, everyone, go ahead and write out this assignment question. I'll be expecting the answers in my DM. So, how you submit the answers to your question are you write it on a paper or in your book, wherever you're writing it. You take a snapshot of it and then you send me the image in my WhatsApp DM, okay? I'll be waiting to
Yes,
see the
sir.
answers to your questions. So, are you all done writing this question?
No, sir.
All right. Hurry up and then we'll call it a day in today's class.
I'm done.
All right, beautiful. Who else is still writing? Are you all done? Are you all done?
Yes, sir.
All right, that's good. That's good. That's beautiful. That's beautiful. Now, since everyone is done, we've come to the end of today's class when we'll be able to define the concept of what the empirical formula of a compound is. In our next class, we're going to be talking about calculating the molecular formula. We're going to be seeing how you can get the molecular formula from the empirical formula. In today's class, we saw how you can get the empirical formula if you have the molecular formula. You simply divide it to its lowest term. In our next class, we're going to be seeing how you can get the molecular formula if you are given the empirical formula. So up until then, I want you to go through the assignments, do them. If there's any question or anything you are not sure about, please feel free to reach out to me. I am just one DM away, and I will see you in our next class. David, Nifemi, the second David, and the third one, I'm Francis. Thank you for having this class with me. I'm super excited you came along. I'll see you in the next class. Bye for now.
Thank you, sir.
Bye.
All right, bye.